Today we have an offset deformable barrier crash test. This test is mostly used for the calibration of restraint systems and, of course, to validate the behavior of the crash test dummies inside the car. I'm Petar Marjanovic. I'm the trim engineer from Vehicle Engineering Division.
On the first prototypes, we already had full vehicle tests, and that was more for the correlation with the simulation and to see if we are going in the right direction. We did a sled test, we did the static deployments for collecting data for fitting the restraint systems. You have first some material testing to get a good material correlation, then you're going on the part testing, some low speed, some high speed parts testing, and then with all of this correlation you have the full vehicle in a simulation and you have to correlate that with real testing. I'm Martin. I'm from Rimac company, senior CAE engineer. I'm doing the simulation, so what the design engineers do, I have to put in my FEM software to create some simulation of the events that we are doing now, for example here on the real testing. Simulation of the metals are today on the high level, but for the composites it's still not so well-known area. The orientation of the composite is important. It behaves different in different directions, so it's not so easy to simulate that. But we can get some overview of how this will look. And after the test, I can immediately see how close I am with my simulation with respect to the normal testing.
What we are trying to do here today is to understand whether the dummy is hitting any parts of the interior of the car. If it does, to make sure that those hits are not creating excessive loads on any of the dummy parts so that they absorb enough energy to keep the occupant safe. What we also include in the trims is the restraint system, so we are evaluating the performance of the seat belts, complete with pre-tensioners, with load limiters and airbag performance as well.
Also, what we are looking at the structure, how it behaves, what we can improve, what we need to improve, what we don't, what is good. Generally, that's it. Quite destructive test, but it's 40 km/h, and in Friday we have 56. That is almost double the energy, so it will be even more interesting.
We knew that the kinetic energy that we are taking into the crash is double compared to the previous test. That deflation, they actually help slow the dummy down instead of just bounce it back into the seat. So that's what dissipates the energy. Right now we know that all of the readings were in the green. The risk of injuries on the dummies was very low and well below the required values. So we know that the dummies survived reasonably well. One thing that we also were keen to see, and that's the intrusion of the pedals and the footwell, especially on the driver's side, because the pedals present a high risk of injury. As we can see, there's absolutely no sign of cracks in the tub, meaning that the footwell remained incredibly stable. All of that comes from the massive destruction that we saw at the front of the car. So all of the energy was dissipated before it reached the passenger compartments. After seeing this, very confident, especially as we were expecting that this test would be one of the toughest that we have to pass, and seeing the results that we got, there was a surprise with the integrity of the front end of the car, but as much as we were surprised by that, we were also very pleased with the results inside the tub, inside the passenger compartment.
The value that we see basically disappear in milliseconds
2 times during 2 days is enormous. However, the result of that is much more important than the value that we invested into this development.